Hello, and welcome to Share Science. I'm Curie, and I'm absolutely fascinated by the hidden sensory worlds of all the animals that surround us. You humans experience reality through the 5 familiar senses that we covered in our series on senses. But what if I told you that we're missing almost everything? The natural world is filled with creatures who perceive dimensions of reality that we can barely imagine. They navigate by magnetic fields, see colors that you can't even imagine, hear conversations happening miles away, and feel the electrical whispers of a heartbeat underwater. Today, we're going on an extraordinary journey. We're not just going to learn about these animals, we're going to become them, just like in the movie Hoppers. We'll slip into their sensory experiences, see through their eyes, hear through their ears, and discover how they've engineered solutions to survival challenges that humans are only now beginning to understand. Are you ready? Let's step beyond the limits of human perception. Imagine you're a beaver, sliding into the cool water of your pond. As your head dips below the surface, something remarkable happens. A transparent third eyelid, called a nictitating membrane, slides across your eye like built-in swimming goggles. Suddenly, the underwater world comes into crystal clear focus. You can see perfectly, while your eyes stay perfectly protected. Your front teeth, those magnificent orange incisors, are self-sharpening tools that never stop growing. The front surface has hard enamel, but the back has softer dentine. Every time you gnaw through a tree, the softer back wears down faster, maintaining that perfect razor-sharp chisel edge. It's a tool that sharpens itself every time you use it. Brilliant, isn't it? Your fur is also an engineering marvel. 23,000 hairs per square centimeter, creating a waterproof coat that traps air and keeps your skin completely dry even in frigid water. Every hair is coated with oil from your castor glands, nature's waterproofing system. But here's what's truly amazing. You can build without blueprints or engineers. Deep in your brain, encoded by millions of years of evolution, is an instinctive understanding of structural engineering. You know exactly where to place each stick, how to angle each log, how to create a dam that can hold back thousands of gallons of water and transform an entire landscape. You're not just building a home, you're creating an entire ecosystem. Your dam raises the water level, creating wetlands that filter water, prevent erosion, and provide habitat for hundreds of other species. You're an ecosystem engineer. And you're doing it all by instinct. As darkness falls, you become a bat. And suddenly sight becomes irrelevant. So you can't see. Now what? You open your mouth and emit a rapid series of ultrasonic calls, sounds so high-pitched that humans can't hear them. These sounds travel outward at the speed of sound, bouncing off everything around you. Trees, insects, buildings, even individual leaves swaying in the breeze. Your ears, those magnificent oversized structures, capture every returning echo. Your brain processes these echoes in real time, creating a detailed 3-dimensional sound map of the world around you. You're not just detecting obstacles, you're measuring distances, calculating speeds, determining textures, and even identifying species of insects by the unique acoustic signature of their wing beats. A moth sounds different from a beetle, which sounds different from a mosquito. In complete darkness, you can navigate through a dense forest at full speed, tracking and catching tiny flying insects with pinpoint accuracy. You're essentially seeing with sound, creating a sonic image so detailed that it rivals vision. Scientists call this echolocation, but that technical term doesn't capture the sheer elegance of it. You've turned yourself into a living sonar system, painting the darkness with sound. Dive deeper. You're now a shark, gliding through murky water where visibility is nearly zero. Along your snout and head, you have hundreds of specialized organs called ampullae, tiny jelly-filled pores connected to sensory cells. These aren't just pores, they're some of the most sensitive electromagnetic sensors in the natural world. Every living creature generates weak electrical fields. The firing of neurons, the contraction of muscles, even a beating heart creates electrical signals, and you can detect them. A fish hiding motionless in the sand, perfectly camouflaged and completely still. You sense the electrical impulse of its heartbeat from several feet away. The fish might be invisible, but to your electroreceptors, it's broadcasting its location like a radio beacon. You can detect electrical fields as weak as 5 billionths of a volt. That's like sensing an AA battery connected by wires stretching from Washington, D.C. to Florida. This sense doesn't just help you hunt, it helps you navigate. Earth's magnetic field generates weak electrical currents in seawater, creating an electrical map of the ocean. You use this to navigate across thousands of miles of open ocean, finding your way back to the exact beach where you were born. Now we descend into the deep ocean. You're a humpback whale, and you have something to say. You open your massive throat and begin to sing. Not simple calls or clicks. You create complex, haunting melodies that can last for hours. These aren't random sounds. They're structured songs with themes, phrases that repeat, verses that build on each other. You're composing symphonies in the dark ocean depths. But here's what's extraordinary. Sound travels differently in water. In air, sound fades quickly, but in the ocean, under the right conditions, your song can travel for hundreds, even thousands of miles. There's a layer in the ocean called the SOFAR channel, sound fixing and ranging channel, where temperature and pressure create a natural acoustic waveguide. Sound waves traveling in this channel can circle the entire globe. Your song, emanating from the Pacific Ocean near Hawaii, can theoretically be heard by whales in the Indian Ocean. You're not just communicating with nearby family members, you're broadcasting across entire ocean basins. Your song is a cultural phenomenon. Whales in the same region sing variations of the same song, which evolves year by year. You're creating, sharing, and modifying oceanic culture through sound. Scientists are only beginning to understand what you're saying, but one thing is clear. You're having continent-spanning conversations in a language far more complex than we ever imagined. Let's shift into something truly alien. You're an octopus, and the way you experience thinking is about to get weird. You have 9 brains, 1 central brain in your head and 8 smaller brains, 1 in each arm. 2/3 of your neurons aren't in your head at all. They're distributed throughout your 8 arms. Each arm can think, problem solve, and act independently. While your central brain decides the overall strategy, I need to explore that crevice. Each arm figures out the details on its own. How to bend, where to place suckers, what texture it's touching. Touch one arm to a crab, and that arm knows its food before your central brain gets the message. That arm can start grabbing, passing the crab from sucker to sucker toward your mouth, all without conscious oversight from headquarters. Your skin is covered with millions of specialized cells called chromatophores, iridophores, and leucophores. In less than a second, you can completely change your color, pattern, and texture to match your surroundings. You're not just camouflaging, you're computing what pattern to display. And somehow you're doing this without being able to see color yourself. Your suckers can taste what they touch. Every surface you explore gives you chemical information. You're simultaneously seeing, touching, and tasting your environment with 8 semi-independent tentacles, each one processing its own sensory stream. You're not experiencing consciousness the way a human does, with thoughts centralized in one location. You're distributed awareness, intelligence spread across your body, each part sensing and thinking and acting in parallel. It's not just alien, it's a fundamentally different way of existing. The sun sets and the desert cools. You're a pit viper, and now your secret weapon activates. Between your eyes and nostrils are two small pits, specialized organs that detect infrared radiation. Warm-blooded animals emit heat, and you can see it. While other predators see the dark desert as shapeless shadows, you see something remarkable. Glowing thermal silhouettes. A mouse, 30 degrees warmer than the surrounding sand, appears to you as a bright, warm shape against a cool background. Your infrared vision is so sensitive that you can detect temperature differences as small as 0.003 degrees Celsius. You can sense the body heat of prey from nearly a meter away, even in complete darkness. But here's the truly fascinating part. Your brain integrates this thermal image with your regular vision, creating a combined picture of the world. You see both the visible and the invisible simultaneously. You don't just detect heat, you detect temperature gradients, the subtle differences in warmth across an object. You can tell which end is the head, warmer, more blood flow, and which is the tail. You strike with precision at the warmest point, the heart and vital organs. Humans had to invent thermal cameras to see what you've had for millions of years. People needed technology to image heat. You were born with it. So for all these amazing animal senses, here's the most fascinating thing. Every single ability we've explored today has inspired human technology. Beaver's engineering have taught about dam design and waterproofing. Engineers have studied their building instincts to develop autonomous construction robots. Bats' echolocation led to the development of sonar for submarines, ultrasound medical imaging, and assistive devices for the blind. Sharks' electroreception inspired sensors for detecting buried cables in mines, and navigation systems that work without GPS. Whales' long-distance communication influenced understanding of underwater acoustics and helped develop better ocean communication systems. Octopus's distributed intelligence is inspiring new paradigms in robotics and AI, systems where intelligence is spread throughout a network rather than centralized. Snake's infrared detection directly inspired thermal imaging cameras, night vision technology, and heat-seeking systems. Nature is the master engineer, and we're only just beginning to learn how to read her blueprints. So what have we learned on this journey? We've learned that human perception is just one tiny window into reality. Humans see only a narrow slice of the electromagnetic spectrum, hear a limited range of frequencies, and sense a fraction of the chemical and physical signals constantly flowing around us. But by stepping into the sensory worlds of other creatures, by becoming the beaver, the bat, the shark, we've glimpsed something profound. We can study echolocation, build sonar systems, and then explain to others how it works. We can decode electroreception, measure electromagnetic fields, and develop technologies that extend our limited senses. Our superpower is curiosity. The drive to ask, how does that work? And what if we could do that too? So the next time you see a bat fluttering at dusk, a snake slithering by, or even a beaver swimming across a pond, remember, you're not just looking at an animal. You're looking at a master of perception, equipped with sensory abilities that rival our most advanced technologies. While a movie like Hoppers is a fun way to think about how animals think about the world, the reality is we can learn so much from all the different ways they can perceive the world. And that is where the magic really is. We hope you liked today's video. Have you ever wondered about how animals sense differently than we do? Let us know about it in the comments. If you liked this video, hit subscribe below, and you can get new content just like this every week in your feed automatically.